All right. Okay. All right. So this topic is going to cover storage management. So the previous um, topic we finished was software management. All right. So storage management. All right. So, all right. So storage management. All right. So do you recall the three main partitions that you need in order for your system to boot up?
It's going to be your root, boot, and swap.
Yep. Yep. Root, boot, and swap. Yeah, so root, boot, and swap. Those are the three main partitions. So if I do a df minus h, uh, you can see our root partition. There's the first one. Root partition is always the first one. And that was what, 10,000 megabytes. That's what we gave it. That's basically 10 gigs. So this is 9.8 gigabytes, which is 10 gigabytes. And then the boot partition, we gave it 500 megabytes. So partition that with 497 megabytes. So our swap partition is not listed here, but to check swap, check the swap partition, you'll execute swap on dash s, swap on dash s. So this is basically in kilobytes. So this is 4 gigs. So our swap space has 4 gigs. But that's one way to check swap. You can also do a free dash G. Free dash G will provide your swap. So it's saying 3, which is basically the kind of like, you know what, let's do this in swap dash M. Okay. I'll provide it in megabytes. So 3,999, which is basically 4 gigs. So swap, which is 4 gigs. So we have our root partition, our boot partition, and our swap partition. All right. Okay. So all right. So let's say we wanted to mount a file system. Okay. So we basically, let's say we want to let's say when you create a directory, right? Let's say when you create a directory, like such as your home directory, and let's say you have 400 users, or let's say 2,000 users that get added to your system in a span of, let's say, 3 years. 2,000 users, that's a lot of space that's going to take up on your system. But not just that it's taken up on your system, it's getting taken up on your root file system, because that's where your home directory lives. Your home directory lives in slash and inside of slash. So remember, you go into slash and you do an LL. Everything that's here lives inside of here. So that 10 gigs of space here is being utilized by all of this content that's inside of these directories, right? Except boot, right? Boot is 500 megabytes, but boot looks like it's on its own partition, right? Remember when we created root, boot, and swap, those are on its own partition. Let's say we wanted our home directory, or not just home directory, any directory to be on its own partition, right? Or mounted as a separate file system, right? We did not want it to be using the space on the root file system. We wanted to mount that space on its own partition. So, so what we're going to do, what I'm going to show you is how to mount a directory on its own partition or its own file system. so that it's using its own space that is dedicated to that directory. So we can give the home directory. If you're getting 2,000 users getting added to a system, that 10 gigs, right? That 10 gigs that's here, that's not going to be enough for 2,000 users. It's going to get filled up, and once the root file system fills up, your system will not become accessible. So you'll need to make some adjustments. So you want to mount the home directory on its own partition. So I'm going to show you how to mount a directory, and specify the amount of space that you want on that directory. All right, so the first thing that we're going to do, so this is our Red Hat 7 system. The Red Hat 6 and Red Hat 7, these procedures are exactly the same, no differences at all. All right, so let's say we wanted to, okay, you know what? I'm going to show you guys this way. All right. I'm going to show you an example first, drawn out. Okay. So let's say you have your virtual machine here, right? That's the system that you just built, right? That is your virtual machine, right? That's the system that you just built, right? And let's say you wanted to create a separate file system called home. You wanted to recreate the file system called home, and you wanted to mount it with, let's say, 30 gigabytes. You wanted home to be mounted on a separate partition with 30 gigabytes, right? So the first thing that we're going to do is we're going to add 30 gigabytes to our system. So now we're going to go out and grab 30 gigs, and we're going to add it to our VM, right? So once we now add it to our VM, it then becomes visible. So the first thing that you're going to do with that 30 gigabytes is that you're going to create a physical volume out of that 30 gigabytes. PV. PV stands for physical volume. So you're going to create a physical volume out of that 30 gigabytes. So once you create, you want to create a physical volume out of that 30 gigabytes. So now we just created a physical volume out of the 30 gigabytes. Then the next thing you're going to do is with that same 30 gigabytes, you're going to create a volume group. VG stands for volume group. So you're going to take those 30 gigabytes and you're going to place it inside of a volume group. You're going to create a volume group out of it. And now, once you've created your volume group, so your physical volume is basically your disk, right? Your physical volume is basically the 30 gigabytes. It's basically the raw 30 gigabytes. So hey, all right, so I have my 30 gigabytes of space. Now I'm going to present it to my system. All right, so I'm presenting it to my system as a physical volume. So now it's seeing the space as a physical volume. So now I can take that space, that physical volume space, and now I can create a volume group out of it. So this volume group is actually a group, right? It's a group that now consists of 30 gigabytes. So now this group now is consistent of 30 gigabytes. So from this volume group that consists of 30 gigabytes, I can create multiple logical volumes out of this 30 gigabytes. So I can create a logical volume of 10 gigabytes. So once I create the first logical volume of 10 gigabytes, I'll now check my volume group. I just took 10 gigs from my volume group. So now I have 20 gigs. So now I just created a logical volume for 10 gigs. So now I've created this logical volume, and now I can mount the logical volume as, let's say you wanted to mount it as slash home. So now slash home is now mounted with 10 gigabytes as a separate partition. So I just gave 10 gigabytes to slash home. So now once I run a df minus h, you will now see slash home is now mounted separately, but now it has 10 gigabytes. So I have 20 gigabytes remaining in my volume group. So now I can create another logical volume. Let's say I want to create this one with 5 gigabytes. And now I've created a logical volume with 5 gigabytes. Now I want to mount that logical volume, and I want to call that mount, let's say I want to call it data. So now I have mounted data with 5 gigabytes. So now I've taken 5 from the 20 out of my volume group, which now will leave me with 15 gigabytes inside of my volume group. So now I can create another logical volume. Now I can mount another logical volume. Now let's say I want to mount it with the remaining space of 15 gigabytes that's there. And let's say I want to mount it as slash var. So now var is now mounted with 15 gigabytes. So now once I run a df minus h, you will now see home mounted with 10 gigabytes, data mounted with 5 gigabytes, and var mounted with 15 gigabytes. So once you add the 30 gigabytes to your volume, to your virtual machine, you can now create a physical volume out of it. Once you create a physical volume out of it, you then create a volume group out of it. Your volume group consists of the total amount of space provided from your physical volume. And then you can now create multiple logical volumes from your volume group. And then you can mount those logical volumes. So this concept that I'm showing you is called LVM. And this is called Logical Volume Manager. So Logical Volume Manager, this is one of the topics where you're going to need to practice a lot of, because it's something that you really need to understand. Okay, so I'm going to show you all of this on the command line, but do you have a good idea of this this concept?
Yeah, I think I understand. Basically, it's a way of putting more space to your virtual machine, ultimately, giving it 30 gigabytes of extra space.
Yeah, yes. You add 30 gigabytes of extra space to your virtual machine, and with that 30 gigabytes of extra space, you can now create a physical volume and then a volume group, and then you can mount separate partitions using that space. Yeah, I'm going to show you on the command line. But actually, one of the first steps I wanted to show you first, once you add that 30 gigabytes to your system, you can you will actually need to partition it first before it's added to the physical volume. So I want to show you how to partition that 30 gigabytes first. So partitioning is basically formatting. So basically, if there's anything on that 30 gigabytes, you're basically just wiping it away. And 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 once you partition it, you will see that it was actually partitioned, and you will take that partition, that new partition of 30 gigs, and you'll add it to the physical volume. And then from the physical volume, you'll create a volume group out of it. And now you'll be able to then mount multiple logic volumes from that your volume group. All right, so I'm going to basically show you this on the command line. All right, so I'm on lab 4, so you want to right click, go into settings, and we want to select add. So we're going to add a hard disk. That's the first one, hard disk. Select next, leave the remaining as default, select next again, create new virtual disk, keep it as default, select next again, and now we're going to specify the amount of space that we're going to add to our virtual machine. Now remember, this space that you're pulling is from your laptop, so this is just for practice purposes. So you don't want to add too much space. Don't add space that you don't have, because you can crash your laptop. So I know I have a good amount of space on my system, so I'm actually just going to give myself 30 gigs. Let me actually make sure that, okay. Actually, I'm going to add 20 gigs. I'm going to do some cleaning up. All right, so I'm going to add 20 gigs to my system. So I'm going to hit next. I'm going to hit finish. So now you'll see here that a new 20 gig hard disk is now added to my system. So I'm going to go ahead and select OK. All right, so the command to determine where that hard disk, where to find that hard disk, is lsblk, so list block. So lsblk. So I'm going to go ahead and hit enter. All right, so I want to explain something first to you. So when we first built our system, what did we do? We added 20 gigs to our system. And then we partitioned that 20 gigs, remember? We partitioned it into 3 different components. There was the root for 10 gigs, it was the boot for 500 megs, and there was a swap for 4 gigs. All of that came from that 20 gigs. So it was SDA. SDA is basically the 20 gigs. So SDA, which is that 20 gigs, if you right click and you go into settings, SDA is actually that first hard disk, which is 20 gigs. So SDA is that 20 gigs, that first 20 gigs. That's when we first built our system. And remember, we partitioned our system into 3 components: root, boot, and swap. So we basically chopped up that 20 gigs into 3 different pieces: root, boot, and swap out of that 20 gigs. All right, so we just add another 20 gigs. So we see that first 20 gigs, SDA. We see our boot, our root, and swap. But we don't see the other 20 gigs of space. So you're actually going to have to reboot your system in order to see it. But you're going to run into situations. You're going to run into situations at work where you're not allowed to reboot your system. You're not going to be allowed to reboot your system. So there are ways to detect a new hard disk that you just attached to your system without having to reboot. Yeah, there are actually ways to do that. That's actually something you can Google. You can Google how to detect a new hard disk without rebooting. But I'm going to paste, you know what, I'll paste it into the chat, one of the commands that you can use. So what I just pasted into the chat is a command that you can use to scan your system without having to reboot. All right. So this command here. So you'll type it out exactly like this. So it'll be echo followed by these components here into the sys class SCSI host scan. So let's actually go ahead and execute that. So echo, actually spaces, and then sys class SCSI host underscore dollar I scan. Okay, looks like it did not like this. All right, so I'm going to do host star scan. Um, let's do host 0 scan. Okay, so I did was host 0 slash scan. All right, so uh, host, and when I hit tab a couple times, um, these are basically the different components within your system where it's going to scan to basically locate that new storage. Um, but actually, oh, let me provide you the exact command that I use. Okay. All right. So exactly how I'm doing it now. So so it'll be echo followed by these quotes with the right arrow key with the right bracket um pointing to sys class SCSI host, and the first one you'll start with is host 0 and then scan, and then the next one you'll go to host 1 and scan as well, and then host 2 and scan that host as well, and then 3 you basically continue scanning until you do an LSBLK to check and to see now that we can see this 20 gigs. You see SDB, that is the new 20 gigs that we just added to our system. So that wasn't there before. But if we rebooted our system after we added that space, it would have just come up. But you want to basically scan maybe the first 5 hosts. Just post it in the chat. So we want to scan the first 5 hosts on your system in order to see that newly added disk. So 0, 1, 2, 3. You can scan 0 and then check. You can scan 1, 2, and 3, and so forth. Maybe the first 5, and then you'll check, which will then populate the new disk. So any questions so far?
Yeah, I do have a question. It's a little bit off topic, but what happened was, so I did this LS block,
Mm-hmm.
or list block on my
Mm-hmm.
system, and I have some
Mm-hmm.
very major differences. And I think when I made the second one, I I must have put the wrong partitioning, right?
Okay.
But my question is, can that then be resolved later on?
Share your screen.
Okay, give me 1 second. So here,
I'll stop sharing.
we'll share this guy, share.
Okay.
You see the swap. I don't know if you see my cursor around it.
Yeah. Actually, no. There's no issue there. Um, you have your root and you have your boot and you have your swap.
Mm-hmm.
As long as you have those three, your
Mm-hmm.
system is going to boot up. There's no issue here.
Okay.
Um, yeah, yeah, there's no issue here.
Okay.
Basically, yeah, there's no issue here at all.
Okay.
Um, yeah, root just looks like root and swap are both under. No, there's no issue here. Yeah, there's
Okay.
no issue here at all. It's not going to affect your system when it's rebooting.
Okay. Okay.
Yeah, or when it's booting up. Yeah,
Okay.
so yeah, so there's no issue here.
Alrighty. Yeah, because I saw that and I was like, oh boy.
Yeah, no, that's no problem at all.
Okay. Alrighty. I can stop share now, right?
Okay. Yep.
All right.
All right. So let me share that out. All right. So now I've scanned each of the hosts, and you can reboot your system for it to come up, but you want to scan each of the hosts in order to see that newly added disk. So that's that 20 gigs that we just added to our system. So now, the first thing you wanted to do is you want to partition that disk. So you want to partition that disk first before you do anything. So there are companies where they're going to require you to partition your disk first, and there are companies that are not going to require you to partition your disk. All right, so this process that I'm going to show you is the exact process that you would use to partition your disk. All right, so it's fdisk followed by your disk that you want to partition. So your disk will actually be /dev sdb. So that's where your disks are located. So fdisk followed by /dev followed by your disk that you want to partition. So the disk that we want to partition is sdb. So once you hit enter, it's going to put you into the partitioning mode to partition your system. Okay, so now it's asking me, so we don't know exactly what commands to basically add to this in order to start partitioning our system. Okay, so let's choose that letter M for help. So M, and you hit enter. So now it's giving us options that we can use to take us through the proper process of partitioning our system. So this is going to be a new partition. Okay, this is going to be a new partition on this disk. So we're going to select the option N to add a new partition. So the option N to add the new partition. So let's do N to add a new partition. So I selected N and I'll hit enter. So now it's asking me if I want this partition to be the primary or extended partition. So we are going to always select the primary partition, which is default. So once I hit enter, now I've selected a primary partition. So we want to be able to, we're not going to break up that 20 gigs of storage. You remember when we built our system initially, with that other 20 gigabytes of storage. We broke it up into three, three components. It was root, boot, and swap. We're not going to chop up this storage, so we want to use all of it, right? So since we want to use all of it, we're going to first select the number 1. So yeah, we're going to select the number 1, which is also default. And then once you hit enter, it's going to ask you what, now we want to select the amount of space of that 20 gigabytes of storage that we want to partition. So we want to use all of it, like I was saying. We want to use all of it, right? So we're not going to specify an option. We're going to keep it as the default, which is 2,048 megabytes. So 2,048 megabytes, that is basically 1 gig. So we're starting from 1 all the way to 20. So this number, I believe, is actually in kilobytes. So this number is basically telling me this is the start of your 20 gigabytes. And this last number is telling me this is the end of your 20 gigabytes. So we want to use the whole thing. So we're going to start with the defaults. So we're just going to hit enter. And we're going to end with the default, which is the end of the 20 gigabytes. So we're going to use the whole, we're going to partition the whole space because we want to use the whole space. So I'm going to hit enter again. So what we did was we partitioned using the size of 20 gigabytes. So we use the entire 20 gigabytes. So we partitioned the entire gig, the entire 20 gigabytes of space. So now this brought us back to this prompt here. So let's select M again for help to see what options that it will provide for us. So the next thing we want to do is we want to change the partition system ID. So this is in order for us to be able to use the LVM and in order for able to use the logical volume manager. But the thing is, you don't have to specify this option. It's not mandatory. You can just, we're just actually just going to bypass it. We don't need to make any other changes. So we've partitioned our disk, and now we want to basically save it. So saving it is basically writing the table to the disk and exit, which is W. So I'm going to indicate W, and I'm going to hit enter. So now it's basically partitioned our 20 gigabyte disk. So now let's confirm that that 20 gigs has been partitioned. So if we do another LSBLK, you will see here we have the 20 gigabyte disk, and we have it here that it's also partitioned as 20 gigabytes. But it now was changed from SDB to SDB1. SDB1, and it's used all of the space. It's used all of the space. So that's basically essentially what it means to partition. So you can either break it into multiple pieces like we did here when we built our system initially. So it was SDA and it was 20 gigs, SDA1, which was 500 megs, SDA2, which was 9.8, and SDA3, which was 3.9. So, but in this case, we did not break it up that way. We wanted to use the full amount. So that's why when we got to the sector section up here, we specified the whole amount from start to finish, which gave us the whole 20 gigabytes of space, which is SDB1. So now, so do you have any questions there, Ugo? I know I'm throwing a lot at you.
No, I don't. I don't have any questions.
Okay. All right. So now we've partitioned our disk. So now the next step, so we've partitioned our 30 gigabyte. So now what we need to do is we need to create a physical volume out of our 30 gigabytes of space. So physical volume is basically just adding that disk to it's you're not making any changes to the disk. You're just basically like prepping that disk to be able to get it through the process of creating a someone else. Okay. Yeah, to be able to get through the process of then being able to create a logical volume out of that disk. All right. So now we want to create a physical volume out of that disk. So to create a physical volume is PV create. PV create is to create a physical volume. So PV create followed by the disk, which is SDB1. So we're using SDB1. So we've partitioned it to SDB1. So PV creates dev SDB1. So you hit enter. So now it's telling me physical volume dev SDB1 successfully created. So now we've created our physical volume. So that is checked. So the next thing we want to do is create our volume group. So now we want to place that 20 gigabytes of space into a volume group. All right. But now let's check first and make sure that our physical volume has been created. So there's two ways to do that. Let me clear my screen. So you can either run a PVS. Let me see, hit enter. It's telling me that we have a physical volume, PV, which is dev SDB1. And then the size is 20 gigabytes. And it has free space of 20 gigabytes. So we've created a physical volume of that 20 gigs, which is SDB1. So now the next step is to create. Okay, there's two ways. So PVS and PV display. So PVS and PV display. So PV display will provide some more detail on that physical volume. Let me clear my screen and let's run that again. PV display. So PV display will tell you dev SDB1 is a new physical volume of 20 gigabytes. So the physical volume name is dev SDB1. The physical size is 20 gigabytes. So that's provides you some few details. So the next thing we want to do is we want to create a volume group out of this new physical volume space. So now we've created a physical volume. So to create a volume group, which is actually a group, so to create a volume group is VG creates followed by the name of the volume group that you want to provide it. So let's call this volume group VG1. So that's the name that we're going to give this volume group. So VG create followed by the name of the volume group followed by the disk. So the disk is dev SDB1. So the disk is dev SDB1. So we're creating a volume group now out of that physical volume. So now, but the volume group name is called VG1. So now once I hit enter, it says volume group VG1 successfully created. So now let's check and confirm that our volume group has been created. So to check to see if a volume group has been created, you run a VGS. You can run VGS, and once you hit enter, it tells you your volume group. That group name is VG1. Now VG1 has what? 20 gigabytes of space. And that space has 20 gigabytes of free space. So we've created volume group VG1. VG1 has a physical volume. Remember that. That's that physical volume here that we created out of it. So VGS will show us our volume group. And now, another way to check your volume group is to run a VG display. VG display will provide some more detail on your volume group as well. So it provides the volume group name, which is VG1, provides the format, and some few details as well. The volume group size is 20 gigabytes, and some few other parameters here as well. All right, so now let's clear that screen. So now what have we done? We formatted our 20 gigabytes. We've created a physical volume using PV Create, and we've created a volume group, which was VG1, out of that 20 gigabytes of space. So now that we've created a volume group, now we have a volume group. So now what we can do is we can create a logical volume out of this volume group. So now let's create a logical volume out of this volume group. So now let's check our physical volume. So physical volume that we created was dev SDB1. The volume group that we created from this physical volume was VG1 using VG Create. So we created a physical volume, then we created a volume group. Now we want to create a logical volume. So to create a logical volume, it's a little complex, but it's not complicated. It's LV create followed by a few flags. So LV create -L. -L will then, you will then specify the size of your logical volume that you want to be mounted. So we want to mount a home, our home directory, as a separate partition. So let's say we want to give it 10 gigs. We want to give home 10 gigabytes. So we would specify 10 gigabytes for the partition that we want to mount, for the file system that we want to mount. And now it'll be followed by -N. -N will then be followed by the name of the logical volume. So the name of the logical volume, I'm going to call it home, because that's what I want to mount. So I'm going to call that logical volume home. And the last thing we're going to specify is the volume group name. So the volume group name was what? We gave it VG1. So that's the volume group name. So we want to create a logical volume with 10 gigabytes, and that logical volume name is going to be called home. But where are we getting this 10 gigabytes from? We're going to pull that 10 gigabytes from VG1. VG1 has what? 20 gigabytes. So the last thing we're going to specify is VG1. So LV create -L followed by the size of your logical volume, followed by the name of your logical volume, and followed by the volume group name. That's where you're going to be getting your space from. So now once I hit enter, it's telling me logical volume home is now created. Logical volume home is now created. The logical volume is now created. So now the logical volume is created. how do we check to see if it's actually been created? So to check to see if your logical volume is created, you can run LVS. LVS. So LVS will tell you the logical volume that we created was home. We created home under the volume group VG, VG1. Volume group LV is logical volume. We created home. The volume group that we created home under was volume group 1. The logical volume size was 10 gigabytes. So now we took 10 gigabytes from our volume group. So it was no longer going to have 20 gigabytes of free space. So how do we check to see how much space is in our volume group?
You can do a VGS or
Yep.
VG display.
Yeah. So VGS. So the volume group size was 20, but now we have free space of 10 gigs because we took 10 away. So 20 minus 10 is 10. Now it's leaving us with 10 gigabytes of free space. Or you can do a VG display. So VG, okay, VG display, if you look at the bottom here, the volume group size is 20 gigs, and the free space is now 10 gigabytes. That's what is now free. All right, so now we've created a logical volume. So you can do LVS or you can do LV display. LV display is going to provide you some details on your logical volume. So home is your logical volume. So home, the logical volume path that home is located in dev, VG1, home. That's where the logical volume home is located. The logical volume name that we created is called home. The volume group that home was created under is VG1. And it provides you some other details. The logical volume size is 10 gigabytes and some other parameters here as well. All right, so now we just created the logical volume home. So now we want to mount it. You know, if we do a df minus h, it's not showing up here. We don't see /home. It's not showing up here. It's still here under our root file system. It's still here under root file system. So remember, if we're creating 2,000 users and we place those users all here, it's going to fill up all this space. We only have 8.5 gigabytes here. It's going to fill this all up because other components on the system are going to be used here as well, not just our home directory. So we want to mount home on a separate file system. So in order to do that, you need to edit a file. You need to add some contents to a file. And that file is called, it's in your etc, and it's called fstab. So you want to edit your etc fstab file. All right. So this is our etc fstab file. So it already has some contents already populated in here. And you remember, these hashes basically indicate that anything that's hashed out is not being read inside of the file. So this content here looks like it's not hashed out. And it looks like it's related to root, boot, and swap. Root, boot, and swap. Remember when we built our system up initially? When our system is booting up, it's actually going to read this file and it's going to mount anything that's inside of this file. So it mounts our root, our boot, and our swap partition. It actually mounts that. So anything that we place inside of this file is going to get mounted. And when anything is mounted, you check it by running df minus h. So we see our root partition and our boot partition. Our swap partition You're not going, that's the only partition you're not going to see here when you run a df-h. You're not going to see swap partition here. So now let's go back into our fstab file. So now let's go to the bottom of that file. All right. So now we want to place the logical volume contents in this file, and we want to specify how we want to mount it, what directory we want to mount it as, and other components that we're going to add to the to the logical volume. But before we do that, actually, let me exit out of this file. Before we do that, so we just created this logical volume home. We just created logical volume home. After you create your logical volume, you want to then create a file system type. You want to create a file system on top of your logical volume. So this is Red Hat 7. So to create a file system, it's mkfs dot followed by the file system type. And if you remember, and towards the beginning of the class, there are 5 different file system types. You have ext1, ext2, ext3, ext4, and you have xfs. So ext1, 2, 3, and 4 can be used both in Red Hat 6 and Red Hat 7. XFS can only be used in Red Hat 7. XFS can only be used in Red Hat 7. So the file system type that we're going to specify, so if you want to specify your file system type, you'll either do ext4, ext2, ext3, ext2, or ext1, or XFS. So we want to create a file system type on top of the logical volume. So now we want to specify, so you'll do mkfs.xfs followed by your logical volume path. And how do we find our logical volume path? That will be LV display. So this is our logical volume path, dev vg1 home. So this is where we want to create our file system. So if we do an mkfs.xfs, and we can use XFS file system type because this is a Red Hat 7 system, then followed by the path of where your logical volume is located. So the logical volume path is located in dev vg1 home. So now once we do that, this is now going to basically finalize the creation of our file system. So now it's created a file system on top of that logical volume. So the logical volume home now has a file system of XFS. All right, so now we've created the file system. So now we want to go back into fstab, and we're going to place the content in here that we want to be mounted. All right, so now let me exit out of here really quick. All right, so if you want to check and make sure that your logical volume has a file system created on it after you've created it, you can run a command blkid, block ID. So once I do block ID and I hit enter, you'll see at the very bottom, dev mapper vg1 home. So this is actually our logical volume home. And if you look all the way to the right, you'll see this is the UUID of the logical volume, as well as the type, which is XFS. So the type of file system that we just created when we did mkfs.xfs, this is where we are able to determine what file system type has been created on our logical volume home. So this dev mapper vg1 home is what we are going to basically include when we are mounting our file system. So we're going to go back into fstab. Once you go to the bottom of the file, so our line is going to say dev mapper vg1 dash home. So this is basically our the first locate. This is our logical volume, which is home. So it's dev mapper vg1 dash home, and then followed by where we want to, the directory that we want mounted. So the directory that we want mounted is /home, right? Even though we created the logical volume home, it doesn't mean it has to be mounted as home. You can mount it as data one, right? But we want to create this as home. And then you're going to specify the file system type. So the file system type that we chose was XFS. And we're going to also then match this content that is also there as well. So defaults 0, 0. So I'm going to have you all do research on this defaults 0, 0. And in our Q&A on Sunday, I want you to all explain to me what information you found on that. So this is exactly how it would look. So we got this information from our block ID, BLK ID. So it's dev mapper vg1 home, followed by the directory that we want mounted, followed by the file system type, defaults 0, 0. So now I'm going to go ahead and I'm going to save the file, and let's check our mounted items. So we still don't see /home here. So in order to mount home, you'll have to create that directory. But that directory is already created, right? It's already created. So if I do an mkdir /home, it's going to tell me, oh, I'm sorry, mkdir is going to tell me the file already exists. File or directory already exists. So now it already exists. So now we can now mount the file system. So to mount it, it's a mount -a. So mount -a. So once we do a mount -a, so we did not get any errors back. If we had any issues, it would have outputted those issues. So now our home directory is now mounted. So if I do a df-h, we will now see at the bottom, home is now mounted on a separate partition with 10 gigabytes. And you see dev mapper volume group home, that's the logical volume. That's actually the LVS. So home is a logical volume that lives inside of VG1 with 10 gigabytes. So home, which is inside of volume group 1, 10 gigabytes, and is mounted on /home. The /home came from here. This is what we mounted this directory as, /home, with an XFS file system. So now home is mounted on a separate partition with 10 gigabytes. So now once our home directory starts to grow with new users that are being added to the system, we now know that, okay, we have a significant amount of space here. So that is how to basically mount a, a file system. So let's say you have 2,000 users that get added to your system. Right now, there are no users added to the system. Once this starts to grow, this will get to about 80%, 90%, 98%. You don't wait for it to get to 100%, because once it gets to 100%, you can get locked out of your system. So once it gets to about, let's say, 90%, you'll get a ticket. You say, hey, Ben, the home directory is starting to fill up. I need you to add some space to it. And that's what I'm going to show you the next class. So I'm going to go ahead and leave it there. Do you have any questions, Ugo? I know I threw a lot at you. Um, I'll upload this video just for you to dissect it a little more. But do you have any questions?
No, I don't have any questions at the moment, but I think what I need to do after looking at this is to go back and create new systems just to
Hmm.
be more just to know how I specified the initial partitions and know and keep track of how much space I'm using for my computer and all that stuff. Oh, actually have
Yeah.
a question. I'm sorry. I actually have a question.
Hmm.
So I'm going to
Hmm.
share my screen so you see what type of memory my computer has, and
Okay.
then we'll take it from there.
All right. So before you share your screen, give me 1 second. All right. So that ends the storage management just for creating a file system. So we have a few more other items for storage management to cover. So that will get covered next class. So I'm going to end it right there for storage management.